The derivation sheet serves as a guide for transforming complex, twisting tensor interactions into simple, predictable scaling factors. This transformation is best understood through two distinct conceptual frameworks: a state diagram that tracks the logical learning path and a sequence diagram that details the operational flow of the information. The state diagram. A logical progression. The state diagram within the derivation sheet outlines the journey from visualizing specific three-dimensional symmetries to understanding how these concepts expand into higher dimensions. Filtering the noise. The process begins by visualizing a three-dimensional grid of index combinations. The narrative here focuses on how the inherently antisymmetric nature of certain tensors acts as a filter, canceling out irrelevant noise and leaving behind a clear signal. Dimensional expansion. As the viewer moves through the demos, the focus shifts to how the resulting constant grows as more dimensions are added. This stage demonstrates that as the degrees of freedom increase, the number of valid internal paths for these interactions grows factorially. The final realization. The state diagram concludes by emphasizing the practical value of this transformation, replacing tedious, repetitive calculations with direct and efficient mappings that restore symmetry to complex physics operations. The sequence diagram. An operational flow. While the state diagram tracks the why, the sequence diagram illustrates the how, focusing on the step-by-step evaluation of these tensor products. Scanning for permutations. The sequence begins with the system iterating through all possible index combinations. This involves checking every potential path, ranging from 9 combinations in 3 dimensions to dozens in higher dimensions, to identify which ones contribute to the final result. The symmetry filter in action. Just as in the state diagram, the sequence highlights a filter that discards combinations with repeated elements. This ensures that only unique, non-zero permutations are permitted to pass through to the next stage. Building the running total. The diagram depicts a running total that accumulates in discrete jumps. Each successful hit from a valid permutation adds to the sum until it reaches a specific constant, which acts as a counter for the valid ways those internal paths can be rearranged. Achieving efficiency. The final step of the sequence shows the transition from a complex series of flips or rotations to a straightforward identity or scaling operation. This effectively replaces a loop-based process with a direct result, significantly increasing computational and analytical efficiency.